Okay. Sample final exam. Run through with no plots. I've never tried this angle before, but I'm too cheap for a tripod. Problem one is the time tick. We notice that we're using a stopwatch instead of using the regular watch time method, so we can skip doing a difference of watch time. We just start with our 1600 and 0 seconds tick. We have stopwatch time, which I'm abbreviating to ST as 0 hours, 3 minutes, 19 seconds. To get UTC time at time of observation as 16:03:19, and subtract from that chronometer time of 15:59:46. 46 from 19 is 19 minus 46 is negative 27 plus 60, 33 seconds. Take away 1, make 3 a 2. 2 minus 59 plus 60 is 3 minutes. And make this 16 into 15. And 15 minus 15 is 0. So we're 3 minutes, 33 seconds slow. We observe the lower limb of the sun with a sectioned altitude of HS, a sectioned altitude in HS of 28 degrees, 24.7 minutes on the 17th of May. The index error is 1.5 minutes off the arc. So HS, 28 degrees, 24.7. We're 1.5 off the arc, so we put it on. Our height of eye is 86 feet. So we're going to use our dip table in the front, and we are going to have to use the one that we have to interpolate because we can't use our critical table. At 85 feet, we have 8.9, and at 90 feet, we have 9.2. A difference of 0.3 minutes every 5 feet. 86 feet is just one more, so that'll just be 0.3 divided by 5 times 1 plus 8.9, giving me 8.96, which I'm going to round to 9.0 minutes, which we subtract as dip. So 24.7 plus 1.5 minus 9.0 gives me HA of 28 degrees 17.2 minutes, which I can further correct using our lower limb table. It is May. May is between April and September, so I just find app out of 28 degrees 17 minutes. I have 28:33, 27:13. We use the number between 14.2 plus because it's lower limb, so plus 14.2 minutes for refraction. For 34.8 minutes, 28 degrees, HO, sun, lower limb, and no time associated. This one is an azimuth by the sun. All of our stuff is given to us. Our lat is 28 degrees, 34 minutes south. Our deck is 4 degrees, 22 minutes contrary. So we enter it negative in our calculator. Our LHA is 289 degrees, 47.9 minutes. East, so we'll also enter that negative in our calculator. So 460 plus 28, so 1. 22 over 60 plus 4, negative, store 2. 289 plus 47.9 over 60, negative store 3. The azimuth, Z, well, azimuth angle, recall 3 sine divided by open parenthesis, recall 1 cosine times recall 2 tangent minus recall 1 sine times recall 3 cosine, close bracket, equals second tangent plus 180 because that's a negative number, so we don't even think about it. Z is south 103.7 degrees east. And we can just use our regular great circle azimuth equations for that. So Zn equals 180 minus Z because we're south, because we're in the south and the body is to the east. So do minus plus 180. Zn equals 76.3 degrees true. And then I just set up true virgins. True virgins make dull company at weddings. Our standard compass observation was 0.84 degrees PSC. Our variation in the area is 11 degrees west. We were plus because we're at west at weddings. Our true is this same 0.76.3, and since I didn't clear this on my calculator, I just do plus 11 to give me magnetic of 0.87.3 degrees, and then the difference from 87.3 to 84, just do minus 84, and since that was minus, I have 3.3 degrees east is my deviation. A azimuth by Polaris, this time with a double get. So G plus E equals T for azimuth. Transfer. G plus E, same E, equals T for heading. And I can just continue forward with that one with the T. VMDC. My LHA of Aries is 79 degrees 47.5 minutes. That's given to me. So all I have to do is hop into my Polaris table on the back. LHA of 79 degrees 47.5. I'm going to use this column. Not sure if you can see it. Great. And my latitude is 33 degrees 48 minutes north. So I'm between 20 and 40. And this is only a difference of 1/10 of a degree, so I'm just going to choose this one because it's closer. 359.3 is my true. My gyro observation was 359.8, so my gyro error is 0.5 minutes west. West, so that's minus here again. My gyro heading was 224 degrees PGC, so 224 minus 0.5, 223.5 degrees true for my true heading, and now we're going to be adding west. So variation is 2 east, so we subtract minus 2, 221.5 degrees magnetic, and my standard compass was 222.5 degrees per standard compass, so that is 1 degree west deviation. Okay, another Polaris question. So I'm just going to use these same tables. My LHA of Aries is 200 degrees, 33.2, so that's going to come pretty much to 200.5. Though I do have to correct this HS to an HO, so I'm just going to start with that. 40 degrees, 35.8 minutes, and I'm just going to set, oh, we have a DR latitude of 41 degrees, 10 minutes. So I can get all of my A corrections right away. So in my table for 200 degrees, 200 and 0 is 146.7, and 201 is 146.9. 7.9 is 0.2, halfway is 0.1, so A0 is 1 degree 46.8. A1 for latitude without interpolation, 40 degrees, 0.6. My A2 for the month is June, so I will be using 1.0 minutes. Subtract our -1 magic degree to cancel those. So our total correction is 46.8 plus 0.6 plus 1. So 48.4 minutes plus for our total correction. And so now we can just use our star table in the front. Our index is 2 minutes on the arc, so we take it off. Our height of I is 40 feet, so we're going to use 6.1 as our correction. Take it off for dip. 35.8 minus 20 minus 45. 35.8 minus 2. 35.8 minus 2 minus 6.1. 40 degrees, 27.7 is my HA. Using stars and planets for 40, 27.7. 40 degrees 08 to 42 is minus 1.1 from our stars and planets table, so that's 40 degrees, 26.6 is my HO. And then add 48.4 minutes for my A total. 6 and 4 is 10, carry the 1. 6 and 8 is 14, with the 1 is 15, carry the 1. 2 and 4 is 6, 1. 41 degrees, 15 minutes, north, flat. And the time was 2010. Deviation of the magnetic compass by amplitude. I observe the sun in the east, so I'm going to use 0600 as my start time. My time zone is 19.4 over 60 plus 1460 divided by 15 minus 10. So 6 plus 24 minus 10 gives me 2000 UTC. My chronometer is 07:55:06, but I really know that that is 19:55:06. And we are 1 minute 11 seconds fast. So our actual UTC time, the correction is 19:53:55, and we just need the declination of the sun for August 23rd because we're on the previous day. August 23rd at 1900, we're 11 degrees 17 minutes north. D is 0.9 and falling, so 55 over 60 plus 53 divided by 60, so that's 0.89 hours, 0.9, so 0.9 times 0.9, 0.8, so it'll be 1117 minus 0.8. North 11 degrees 17 minutes minus 0.8 minutes. Degrees 16.2 minutes north, and that's going to allow us to set up our azimuth equation. Amplitude sine A equals sine dec over cos lat. So 16.2 divided by 60 plus 11 sine divided by open 49.4 divided by 60 plus 26. Our dr latitude is 26.82333. Repeating, cosine of that equals, then second sine A equals east for rising 12.7 degrees north for sun deck. So 090 minus 12.7 equals true. Minus plus 90. And now we can just set up our true virgins again. True virgins make company at weddings. Starting with 077.3 is true. Variation of the area is 15 degrees west. Our observation was 0.84 degrees per standard compass. So 77.3 plus 15, 092.3 minus 84, 8.3 degrees east deviation. Starfinder question. Don't need our red disc, only need our blue disc. My LHA of Aries is 100 degrees, and I'm in the northern hemisphere, so north plate, north side of 25 disc. Let's just go from the top. Set my arrow to 100 degrees. Actually, let's make it 100.5 since I can. Looking for Arcturus. Arcturus is below the horizon. It can't be A. Looking for Procyon. Okay. Procyon is at a height of 65 degrees high. That's pretty high. And bears 145. Sirius, I should probably move my head so you can see, but if you're working along with this, then you already have a starfinder with you. Sirius bears 180 and is at a height of 50 degrees. Now both Procyon and Sirius are high magnitude, so that might come up later. So we are right, altitude 0, check. Check is going with high magnitude for me. And then Capella is at 65, so that's high again. And it bears 325. It's good on magnitude. So B is looking pretty good. Hamal, Rigel, and Alphard. Hamal is pretty low. I mean, pretty dim. But it is at a good height, so right height, bearing 285. We call that horizontal dash for medium magnitude. Sirius, we already have. Sirius, no, we're looking for Rigel. Rigel's at a good height, bearing 220. And Rigel is bright. Alphard is at 40 degrees, height observed, so that's very good. Bears 125. Alphard is not as bright. For option D, Betelgeuse, W, and Regulus. W, great altitude, bears 030. Not super bright. W, I should have kept the matrix going. Or 30, check. Betelgeuse, very high altitude, extremely bright, bearing 220. Regulus. Where is Regulus? Regulus, right altitude, bears 95. Very good magnitude. So let's consider these in terms of spread. Oops. Got the number backwards. Sirius does not bear 0, that bears 180. But from Procyon to Sirius is not great spread. That's only 35 degrees. We can cross out B. So that leaves these. 285 to 220, short of a sort spread. I'm going to go with this one has better altitudes, but this one has better spread. I would shoot this. Betelgeuse might be hell to get because it's vertical, but I like the spread better. Zone time of sunset at standard meridian. We're going straight west, so our latitude will not change. We're not calculating for longitude. Now, on October 5th, a strange sort of thing happens that makes this question easier. sunset at 20 degrees north, it's 45 minutes, 17:45, and at 30 degrees north, it's 17:41. So that's just 4 minutes difference, and we're at precisely half of that. So it's 2 minutes difference. So 25 degrees using Pearson's linear interpolation, that gives us 17:43. Didn't even have to set up carrots and sticks. Now if it were a sunrise on the same day, from 20 to 30, it's even closer. It's only 2 minutes of spread. So it's given that there's a 3-minute tolerance on this question, couldn't fuck it up. Yes. Zone time of local apparent new. Now I get to bust out the sailings. So, MER passes at 12:05, so I go from 0800 to 12:05. It gives me 5 minutes and 4 hours. Going from 25 degrees, 25 minutes south, 16 degrees, 9 minutes west. My course is 290. .360 minus 290 gives me an internal course angle of 70 degrees. North, 70 west. Our speed is 13.5 knots, so 5 over 60 plus 12 minus 8 times 13.5 knots, 55.125 miles, times 70 cosine, 18.85 minutes north. And in the south, I go north, I get less south, so minus plus 25, 25 degrees, 6, 1 minutes south. I don't really need that. All I really need is the LM, mid-latitude, so we do plus 5 by 2, get 15.6, which is just the latitude in the middle of these two. So 25 degrees, that much south, by 60 plus 25. This is my middle latitude. Now, P equals D sine C. L equals D cos C. This is div lat, and this is east, west, nautical miles. So, and DLO equals P over cosine LM, which is the same as D sine C over cosine LM, which also equals D sine C times cos LM with 1 over x. So, I have middle latitude on my calculator, cosine, 1 over x times distance, 55.125 times 70 sine. Gives me my difference of longitude in minutes west. I'm in the west, I go west, I get more west. So plus 9, 60, 17 degrees, 06.3 minutes west. And I need this, and so the reason I need this is because I need to know how far east or west of my central meridian I am. I know that I'm in time zone +1. So my central meridian is going to be 15 degrees west. I need to know how far east or west of it I am. I know that I'm west, so if I divide by 60 plus 17 minus 15, that gives me 2.10 degrees west of center, which I can convert to time by doing divide by 15 to give me 0.14 hours times 60 to give me 8.4 minutes. So 8.4 minutes late. My central meridian time is 12:05. So plus 5 gives me 1213 local time LAN. For this one I can do something similar. I'm just not going to write out my big equations. I'm just going to do my little setup here. 600 to 1142. 11.7 minus 6 times 12.3 knots gives me 70.11 miles. My vessel's on course 062, so times 62 coast equals 32.9. I'm going north, I'm in the north, so plus 51.9, 60. Latitude 2 is 23 degrees, 24.8 minutes north. Middle latitude is 23.139 minutes. I got that just by doing latitude 1 plus latitude 2 all divided by 2. So, as before, latitude middle, cosine 1 over x times 70.11 times 62 sine gives me my difference of longitude. I'm going west, I'm in the west. So, divided by 60 plus 133 plus 41 over 60. Longitude 2 is 134.8 degrees. I would put it into minutes and tenths of minutes, but we really only need this so we can get our time zone. So I'm just going to divide by 15 right away. Get 8.986. So that's really just zone description plus 9. So 1142 plus 9 local time zone description UTC. 7 plus 9 is 2042. And use the almanac, enter September 12th. Declination of the sun at 2000 is 3 degrees 58.8 minutes. Our D correction is 1.0. We're 0.7 minutes in, sorry, 0.7 hours into the hour. So I'm just going to go ahead and use 0.7, because if we were to check on the 42-minute table of our increments and corrections, 42 minutes, 1.0, 0.7. So (3 degrees 58.1 minutes north). And I know that Pearson prefers a guess and check method, but I like to just draw a sketch anyway. My dr lat is above the sun's declination. Me, the sun, the equator. We have deck. We have 90 minus HO. So this length, them two put together, is lat. I need to convert my HO to ZD, zenith distance, 90 minus HO. So 90 L equals 90 minus HO plus deck for this case. 33.2 divided by 60 plus 70. Our HO is 70.553333. Make this negative plus 90 plus 3 plus 58.1 60 equals, and now just convert that into degrees, minutes, and seconds. L, 23 degrees 24.9 minutes north, 11.2. And I can even though this is our answer, if I were continuing and I wanted my 1200 fix, all I'd have to do is 0.3 times 12.3 times 62 cos plus 24.9. So 1200, our latitude would be 23 degrees 26.6 minutes. And that's how I would advance that line of position for a sun-run sun site. The right ascension of a celestial body. Complement of superior angle 360 minus SHA, or measure east from first